Hi there, it's Matt from Fuzzy Labs, the open source MLOps company. I'm here to talk to you about a competition being ran by our friends at ZenML. In case you don't know, ZenML is an open source tool for orchestrating your machine learning workloads. As for the competition, the goal is to take an innovative and interesting machine learning problem and engineer the MLOps pipeline that sits around that problem. In our case, as you'll have learned from our previous video, we're building a model which can play the game Dobble. Dobble is a card game where you take a pair of cards and you have to find a pair of matching symbols on those cards. And we figure a machine can do this better than a human. We thought to make it really interesting, why don't we run it on this? This is an NVIDIA Jetson Nano. It's a small package, but it contains a lot of computational power, and it's designed for doing machine learning on the edge. Okay, so what's the edge? Well, it's anything where you want to do your machine learning, either your inference or your training, in a way that's physically local. Edge-based machine learning is gaining in popularity. It has a lot of applications, such as smart cities or self-driving cars, and, of course, cheating at Dobble. Which brings me to our plan. What we're going to do is attach a camera to this device. We can plug one in right here. And then we're going to not only deploy the model to the device, but also have some software around that model so that it can interactively play the game in real time. Actually, we wanted to be more ambitious. What we wanted to do was run this device inside a teddy bear so that you could put it at the table when you're playing the game and cheat. However, it turns out this heatsink here puts out quite a lot of heat. We thought that might be a fire hazard. We won't do that. Why do we want to do this on the edge? Well, partly for the challenge, because edge machine learning being an emerging field means that the tooling isn't really matured yet. There's a lot of unsolved problems that we need to tackle. One of the big problems is that we're in a constrained environment. We're limited in our CPU, we're limited in our memory. And it's not like we can just spin up some extra GPUs when we need them. We're restricted to what the device has, and that presents some trade-offs. So when we train our model, we have to optimize it. And by optimizing it, we potentially compromise the performance of the model. But we have to do that in order to run it on the device. So we have to figure out where the middle ground is. There are other challenges, such as how do we deploy the model to the device? And once we have deployed it, how do we maintain it? So how do we keep it up to date? How do we monitor it? Although the Jetson Nano is small, it does have a GPU and it runs Linux, so we can deploy our model as a Docker container. Mind you, it's an ARM platform rather than an x86 platform. So we have to take that into account. And the devil, of course, is in the details. So over the coming weeks, we'll be sharing blogs and videos detailing how we approach training, deployment, and maintaining the model once it's deployed. So if you'd like to learn more about the Jetson Nano, we'll share a link to some of the developer information and you could dive into this exciting world too. In the meantime, thanks for watching, and there's lots more to come, so watch this space.